located in Baku, and here you can see my mobile and email. This is the cover page. Exam is for 1 hour 30 minutes. Let's start. Question 1. Quantities can be scalar or vector. Select the row of the table that correctly states a scalar quantity and a vector quantity. First should be scalar quantity and second should be vector quantity. So we have vectors have directions. So momentum and weight have directions. So scalar quantity is mass and momentum. So we choose A. As lava leaves the volcano, it cools down. Select the row of the table that correctly describes the effect of lower temperature on the viscosity and rate of flow of lava. As temperature drops, viscosity increases, drag force increases, rate of flow decreases. So viscosity increases, rate of flow decreases. Question 3. A car is traveling at a velocity v. The driver applies the brakes and the car accelerates until it comes to rest. The work done by the brakes on the car is W. Which of the following expressions is correct? So here we have proportionality of work to velocities. So first of all, we know that work done equals energy change. Here we have a decrease of kinetic energy, so it becomes 0. So change of energy is half mv squared. So work done is also half mv squared. So we choose answer B, where work is proportional to v squared. Question 4. A man applies a force to a box and the box accelerates. The forces acting on the box are shown on the diagram. According to the Newton's third law, the box will exert a force on the man. So F force man pulls the box. It means that box also pulls man with equal force in opposite direction. So it will be a long friction and it will be F. So the forces acting on man and box equally magnet but opposite in direction. So we choose magnitude F in the direction of friction. So contact force and weight are extra information here. The photograph shows the flow of air around the wing of an airplane. So what we see here? We see streamlines which show lamina. So along streamline shows the direction of velocity. So here we have velocity and constant speed and velocity, and here we have turbulent flow. So which of the following statements about the speed of air is correct? The speed of air at x is constant. Yes, here it is constant. The speed of air at x is continuously changing. Wrong. The speed of air at x is equal to the speed of air. That's a question mark. The speed of air at y is constant. No, because here we have turbulent flow. A ball is dropped from a window and takes 1.6 seconds to reach the ground. Which of the following is the height of the window? So constant acceleration. So we choose formula. So we have u equals 0 from rest, a equals 981, time known. S we should find, so no v equation is this one. So when u equals 0, it simplifies, we substitute values, and we get to two significant figures, 13 meters. Questions 7 and 8 refer to the following information. Increasing forces were applied across the end of a wire, and the corresponding extension recorded. A force extension graph was plotted for the wire. So here we see the point marked X is the elastic limit of the wire. So here we have elastic limit. Which of the following statement is not correct? So F E is the maximum force at which the wire behaves elastically. That's correct. Fx is the maximum force at which the wire obeys Hooke's law. We have no idea, does it obey Hooke's law? Actually, it doesn't obey law because otherwise the graph would be straight line. So B is not correct. Fe is the minimum force at which the wire permanently defaults. That's correct. Fe minimum force at which the wire behaves plastically. So all these are correct. Question 8. The force on the wire was then decreased and the corresponding extension recorded. The values were plotted onto the same axis. Which of the following is the correct graph? So here we see that we have overcame the elastic limit, so we expect some plastic deformation. So after the load is released, we should have permanent extension. So permanent extension we have in C and in E. In E we have as if it didn't recover at all, so this is extreme, so this is more better answer. So C is better answer. Question 9 and 10 refer to the following information. A student carries out a practical to determine the viscosity theta of a liquid. A small metal sphere of radius r is dropped into the cylinder of the liquid. So when we drop ball, first it moves with acceleration and then it reaches terminal speed. The further we okay, let's see what question we have. 9. Elastic bands are placed around the cylinder in the position 1, 2, 3, 4 as shown. The time taken for the sphere to fall between two of the elastic bands is going to be recorded. Which of the following are the best two elastic bands to use? So 3 and 4 is the best because it is more likely that it will reach terminal speed after 3. So, and we are going to measure this terminal speed to find theta. The sphere is made from metal of density ρ metal and the liquid has density ρl liquid. Which of the following expression correctly gives the forces acting on the sphere when they're traveling at a terminal velocity through the liquid? So we have resistive force given by Stokes' law. We have upthrust given by volume weight of displaced liquid, so it is Avogadro law. So upthrust equals weight of displaced liquids, so rho L Vg. Weight equals rho mvg. Mg is mass times g is weight. So when we substitute, we get answer D. Section B. 11. A student carried out an experiment to determine the Young modulus of a material in the form of a wire. The student set up the apparatus as shown. The initial length of the wire was measured. Floated weights of known values were added to the hanger at the free end of the wire. Each time a weight was added, the new position of the marked was read and the meter and the extension calculated. Describe a graphical method that the student should use to obtain a value for the Young modulus. State the additional measurements that would have taken. So initial length x, f is applied weight, new length extension, additional measurement is diameter to calculate. So Young modulus, here we have expression for stress and strain, and here we have formula. So after substituting of this expression, we get that the weights will be proportional to extension, and gradient give us, from gradient we can find Young modulus. but for sure we need cross-sectional area, and for this we need to measure diameter. Two trolleys spring applies equal forces on trolley B and on trolley A. As the forces between the spring and each trolley are equal and opposite due to certain Newton's law, both trolleys experience equal and opposite forces. As if they repel each other, we can forget about the spring media. Explain which trolley will move off with the greater speed. Mass of trolley equals 0.1, mass of trolley B equals 0.2. Momentum is conserved and equals 0 before, and momentum after also will be 0. So momentum equal momentum of A plus momentum of B. Momentum of A is given by mass times velocity. Momentum of B equals mass times velocity. We put minus because they move in opposite direction. When we add, we get that smaller mass we need greater velocity, so A has greater velocity. Child P throws a ball towards child Q at a speed 20 meters per second at an angle 75 degrees to the horizontal. While this ball is in the air, child P throws a second ball, also at speed 20 meters per second, but at angle of 15 degrees to horizontal. Both balls reach Q at the same time. Determine how long the child P should wait before throwing the second ball. So actually we should find the time of flight and then time difference. Time up and down for the first ball, positive direction down, so because it returns back, S equals 0, U equals minus 20 sine in horizontal direction, component in vertical direction will be minus 20 sine 75, and we find we substitute the value, so we use ideas that S is 0, we take T out of brackets, simplify, and we get expression for time. We do the same for the second ball, and we see the time difference, and we calculate this time difference. A musical instrument called a triangle consists of metal bar bent into triangular shape. The triangle is open at one corner. A full-size diagram of triangle is shown below. The position of center of gravity has been added. So, center of gravity, perpendicular distance. State what is meant by center of gravity. The point from which the weight appears to act. This is my correction of Mach scheme. Determines the moment of a weight of a triangle about, or mass of triangle 0.80. So momentum equals force times perpendicular distance. We calculate, and momentum appears to be 23 thousandths Newton meter. The triangle is now suspended by a thread from O. Explain why the triangle settles in position where the base is no longer horizontal. So 2 points. When released, having clockwise moment, triangle turns clockwise until center of gravity appears below point of suspension. In such position, moment of weight is now 0, as perpendicular distance of line of force from point is 0. O is 0. The diagram shows a ship used to carry heavy loads. 2 tugboats are used to guide the ship into port, applying forces as shown. So we have 2 forces at 5 degrees to each other. So we have graph paper. We use scale, for example, 12 newtons 6 centimeter, so it means that 1 centimeter will be 2 newton, and then we find we use triangular rule. We find the length length appears to be 965 centimeters, multiplied by 2 give us 90.3 Newton. And we take into account that it is 10 by 10 to the 4th. And we find angle, and answer should include magnitude and direction to, for example, 12 point times 10 to the 4th Newton. The ship has a velocity 4 meters per second in the direction of the force 1.102 times 10 to the 5th Newton. Calculate the rate at which the work is done on the ship by the tugboat that provides the force. So rate equals work by time. Work equals force times distance. Here we'll have a trick. Let's take time 1 second. Then we can find distance, we can find work, and we can calculate the rate. The tugboat has 2 engines, each of power. Calculate the efficiency. So because we have 2, we multiply by 2. So this is total input power, and we have output power. So we divide useful output by total input, we get efficiency. A ball is thrown upwards with a velocity v1. The velocity time graph for the initial part of the motion is shown. The time of contact with the ground can be taken as negligible. So what we see here, throw upward, so velocity decreases, reaches 0, then it goes in opposite direction, speed increases, velocity increases, strikes the ground, change velocity to opposite, and moves up, so velocity from positive decreases, and finally again reaches the top. So here are answers from Mach scheme. Draw an acceleration time graph on the axis below for the motion of the ball. Okay, first of all, we know that under gravity we have constant acceleration, and we see it from the gradient. Gradient is for straight line is constant, and it is 9.81. Even although we don't see values here, we know it is near the Earth's surface. Okay, right. A 17 student is investigating a spring. He uses steel disc shown in the diagram. So we have here cylinder. Shows that the weight of the disc is about 26 Newton, density of steel. So weight equals mass times G. Rho equals mv, so mass equals density by v, cylinder height by area, circle of area 1/4 pd squared. So taking all this into account, weight will be given by this expression, and it is about 26 Newton. The student drops the disc from a height of 0.3 meters onto a spring. The original length of the spring is 0.110 meters. The maximum compression of the spring is the disc lands in it. It is 0.06. So from this height, and then it falls, compress the spring, and reaches compression will be 0.060. Calculate the change in gravitational Right, so the disk falls from 0.30 to difference of the length 0.110 and the compression. So from 30 to 0,050. The height difference will be 0.25. And we have formulas, a change of gravitational potential energy, mg delta h. We substitute values and we get 6,858 joules. Right. Hence calculate the maximum force that the disc exerts on the spring at maximum compression. Conservation of energy tells us that change of gravitational potential energy equals change in elastic potential energy. So we have graph, and according to this graph, a change of potential energy equals half maximum force by maximum compression. Substituting this formula, rewriting it for F, we get formula force equals to 120 Newton. So this is graph force over compression. Area under the graph equals change of elastic potential energy. Hence determines the stiffness of the spring. So Hooke's law, F equals K delta X, K equals F over delta X is 0,060, force we found, and we get 3,700 Newton per meter for stiffness. Kevlar is a modern lightweight material. Due to its physical properties, Kevlar is being used to replace nylon and steel in many applications. The stress-strain graphs for Kevlar, nylon, and steel are shown. When pulling a heavy load, Kevlar cables are now often used instead of nylon cables. Explain two advantages of using Kevlar in cables compared to using nylon. So first of all, so it is stiffer, so Young modulus is much greater, plus ultimate tensile stress is greater. So Kevlar is, from Mach scheme, Kevlar is stiffer or greater Young modulus. So 4 points. So we should give also detailed explanation. So extension is much smaller under the same load. Kevlar has a greater breaking stress. So it is explanation. So it is stronger. The photograph shows a machine used for surveying the seabed. A communications cable connects the machine to a ship on the surface. The material used in the outer casing of the communications cable must withstand the large pressure at the seaboard, yet be light enough to live on the... So, large pressure, okay. Deduce whether steel or Kevlar is more suitable. So Kevlar even is less dense. So Kevlar is more suitable because it has greater breaking stress, or Kevlar is more suitable because it is stronger. A thinner casing could be used with Kevlar to withstand the same force as a thicker casing made of steel. For the same thickness of casing, the weight of a cable using Kevlar would be much less than using steel. Kevlar would be more suitable than the steel. This is the final resolution. Due to the effect of upthrust, the apparent weight of a cable in seawater is less than in calculate the apparent weight of sample of Kevlar of volume in seawater. So upthrust equals weight of liquid replaced. So it is rho Vg, rho is seawater. Apparent weight will be mg minus upthrust. We substitute values and we get 31 Newton. A yo-yo is a toy that consists of two connected discs on a piece of string. A child stands in a stationary train holding a yo-yo. The train accelerates and this string moves in the position shown at an angle theta to the vertical. So direction of motion is shown. Train accelerates. Draws the free body diagram for the yo-yo when train is. So tension is inward along the string, weight is downward. So here we have, so if we add, we get vector forward, so all objects should have acceleration. Calculate the acceleration of the train by resolving horizontal and vertically for the forces of yo-yo. So we have right angle triangle. So this is weight, this is resultant force. So resultant force will be mg tangent 8 degrees, and acceleration will be resultant force by mass, g tangent 8. So we get 1.4 meter per second squared. Discuss whether the string could ever become completely horizontal or completely vertical while the train is accelerated. Euler accelerates horizontally, so there should be horizontal resultant force. Horizontal component is provided by tension when string is tilted. So no for completely vertical position for string. On the other hand, weight is always present and it should be balanced by tilted spring tension vertical component. So no for horizontal position also. Paper is over. Thank you for your attention. See you next time.